Hello everyone, and welcome back to the Proactive Learning YouTube channel. Today we're going through question 19 from the June 2018 Paper 3 Higher Tier for GCSE Maths. So let's look at what the question is asking us. So question 19 says, here are two right angle triangles. Then we're given the two triangles and we have some labels for them. So some for the lengths and some for the angles. Now we've been told that tan of E is equal to tan of F. And then we're asked to find out the value of X, showing all of our working. So the first thing that we need to think about here is our triangles don't give us much information because we don't know what the value of X is, which we're trying to work out. We're not even given the angle E or F. So in other words, we don't really have a lot of information straight away. But here we need to focus on the significance of this here. So if tan of E is equal to tan of F, how does that help us? So the first thing that we want to think about here is, what does tan of E actually mean? So in class, I'm sure you're aware of SOHCAHTOA. So sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So here, we've been given information about tan of E and tan of F. So we want to focus on the tan part of SOHCAHTOA. So tan is equal to the opposite over the adjacent. So let's find out what tan of E and tan of F are individually. So tan of E is equal to the opposite over the adjacent. But here, what is the opposite? So we look at the angle E here. And what is the length of the side opposite to this angle? And the length is x. So our opposite is equal to x. Now what about our adjacent? So this side here would be our hypotenuse, the longest side of our triangle. So our adjacent is the remaining side, which is 4x minus 1. And all of that is equal to tan of E. So we know what tan of E now equals. It equals x over 4x minus 1. So let's do exactly the same thing now, but for tan of F. So tan of F is equal to opposite over the adjacent. But now for the angle F, what is the length of the side opposite to our angle? And it is 6x plus 5. So our opposite is equal to 6x plus 5. Now, same as in our first triangle, our hypotenuse is the longest side, so we're left with the only remaining side as our adjacent. So our adjacent is 12x plus 31. And that is equal to tan of F. So from here, we know what our tan of E is equaling, and we know what our tan of F equals as well. So the next thing that we need to think about here is, if tan of E and tan of F equal each other, what other two expressions equal each other or are the same as well? And in this case, it's these two expressions here. So the next thing we can do now is make these equal to each other. So x over 4x minus 1 is now equal to 6x plus 5 over 12x plus 31. So from here, we now have an expression with only one unknown, so our x value. So from here, what we want to do is try and get rid of the fraction. If we can get rid of the fraction, it's more likely to make it a little bit easier for us to get to the answer. So how do we get rid of the fraction? Now, in a situation like this, where we have one fraction equaling another fraction, the best way to get rid of the fraction is by doing cross multiplication. Now, cross multiplication is where you times the numerator of one of the fractions by the denominator of the other, and you do the same thing, but with the remaining numerator and denominator. So in this case, we're left with x multiplied by, which I'll represent with a bracket, 12x plus 31, and that's equal to 4x minus 1 times by 6x plus 5. Now from here, let's just expand all of the brackets out and see if we can simplify anything at all. So let's look at the left-hand side first. So x times by 12x is equal to 12x squared. Then x times by 31 is equal to plus 31x. So we've done the left-hand side, but now let's look at the right-hand side. Now the right-hand side, we've got a pair or a set of double brackets. So here, let's first times 4x and 6x together. So we get 24x squared. Then we have 4x times by 5. So we get positive 20x. Then we move on to the negative 1 now. So negative 1 times by 6 is negative 6x. And negative 1 times by 5 is negative 5. Now here, on the left-hand side, we've got an x squared term and an x term. So we can't simplify that yet. But on the right-hand side, we've got positive 20x and negative 6x. So we can simplify that. So let's go ahead and do that. So we have our 24x squared. But now, if we have positive 20x take away 6x, that's the same as positive 14x. And then we have our negative 5. The left-hand side stays the same. So we have 12x squared plus by 31x. Now from here, we can see that we've got a sort of quadratic going on here. We have x squared terms, we have x terms, and we have a constant. So when it comes to quadratics and solving quadratics, what we want to do is bring everything onto one side. But how do we do that? So in this case, we've got 3 terms on the right-hand side and 2 terms on the left-hand side. So to make it a little bit easier for ourselves, let's move everything to the right-hand side, because we'd have to move fewer terms. So let's first look at the 12x squared. How do we move this 12x squared to the right-hand side? And the main way to do this is by thinking about the opposite. So on the left-hand side, we've got a positive 12x squared. But what's the opposite of adding 12x squared? It's taking away 12x squared. So what we can do is take away 12x squared from both sides. Exactly the same thing for the positive 31x now. What's the opposite of adding 31x? It's taking away 31x. So let's take away 31x from both sides now. So if we take away 12x squared and we take away 31x, the left-hand side, we're left with nothing, right? Because we've done exactly the opposite of what's there. But then the right-hand side, we have 24x squared, but now we're taking away 12x squared, aren't we? Then we're adding 14x, but then we're taking away 31x, aren't we? And then we have a negative 5 remaining there. But now, let's try and simplify this. So we have positive 24 lots of something, and we have negative 12x squared lots of something. So in this case, if we have 24 lots of something, take away 12 lots of something, we're left with 12x squared, aren't we? From here, we have positive 14 lots of x, and we're taking away 31 lots of x. So in this case, because it's a calculator paper, you can do 14, take away 31 on your calculator, and we're left with negative 17x. And then we just have a negative 5 remaining. So from here, we've simplified our quadratic. But the next thing that we want to do is actually get a value for what x is. And to do that, we need to factorize. Now, there are many different ways you can factorize. Personally, I prefer the method where you times the coefficient of x squared by negative 5. So in this case, it's 12 times by negative 5. That gets us negative 60. Then we have a negative 17 here. And all you have to do from here is find 2 numbers that times to get negative 60 and add to get negative 17. So in this case, that would be negative 20 and positive 3. So from here, let's look at the right-hand side and factorize now. So we've got our 2 pair of brackets. Now at the start of each bracket, let's just add our 12x. And then we have our negative 20 and our positive 3 to add. Now from here, we can simplify this down. So in other words, we can divide the first bracket by 2. So we have 6x minus 10. We can simplify it again by doing 3x minus 5. And then the right-hand side bracket, we can divide everything by 3. So we have 4x plus 1. So that is fully simplified as well. But something that we need to remember here is this pair of double brackets, it's equal to 0, isn't it? So in other words, let's look at our first bracket. So our 3x minus 5 equals 0. So from here, the opposite of taking away 5 is adding 5 to both sides. So if we add 5 to both sides, we get 3x is equal to 5. But here, we don't want 3 lots of x, we just want x on its own. So then we have to divide both sides by 3, and we get 5 over 3 as one possible value for x. Now let's do exactly the same thing, but now for our second bracket. So here, we have 4x plus 1, and that's equal to 0. Now from here, 4x is equal to negative 1, because what's the opposite of adding 1 to both sides? It's taking away 1 from both sides. Now from here, we want x on its own, so we need to divide both sides by 4. So then our final answer for our second possible value for x is negative a quarter. So the next question you might be asking from here is, we've got 2 values for x, but if we look back at the question tells us find the value of x. So in other words, there's only one possible value for x. But how do we choose which one? So the key with doing this final step is by looking back at our diagram. If we look at our diagram here, let's look at this left-hand side triangle. Now, we have a length here, which is x. Now, if x equaled negative 1 over 4, this length here, it would be negative, wouldn't it? But we can't have a negative length for a triangle. It's impossible. So, in that case, this means x can't equal negative a quarter, because if it did, we would have a negative length for one of our triangles. But then if we had x equaling 5 over 3, in that case, x would be positive here, x would be positive here, and it would be positive for these 2 lengths as well. So it would make sense, wouldn't it? So in that case, what we would say is x can't equal negative a quarter, because then we would have a negative length for one of our sides. So the only other value for x is 5 over 3, and that is our final answer for question 19. So with that in mind, hopefully you guys learned something. Hopefully this answered a couple questions you had about this particular question. Feel free to let me know if there are any specific past paper questions you want me to work through. And that would be it for today's video. So please like, comment, and subscribe. See you later.